Welcome to another video where we have to calculate the current I using superposition theorem. So superposition theorem is only valid when there are two or more than two independent sources. So here we can see there is a voltage source of 24 volts and a current source of 3 ampere. So in order to solve this question, you have to consider both the cases where by considering 24 volts and deactivating your 3 ampere current source, and by considering a current source of 3 ampere by deactivating a 24 voltage source, and obviously have to calculate the current I due to both individual sources. So it can be solved by using two cases, by considering two cases. In the first case, I will consider the effect due to your 24 volts and by deactivating 3 ampere current source. So case 1 is by considering 24 volt source. So if I consider my 24 volt source, my network would be reduced into 24 volts and a 2 ampere current with 2v1 dependent source as we have already seen in the previous videos that we have to open circuit the current source if present any. So I open circuit the current source. So since I have to calculate the current I simply apply my KVL to this network, which is minus to plus, that is from anti-clock, that is your clockwise direction. So by applying KVL you get minus 24, that is from minus to plus polarity, and here voltage drop across 2 ohm is nothing but your current times resistance, which is, since the current flowing through this branch is current I, so my voltage drop across 2 ohm resistance is current times resistance, which is plus 2 into I, and the dependent source is from minus to plus, so minus 2v1. So and the voltage drop across 4 ohm is nothing but the current that is flowing through the 4 ohm and times resistance, so into 4, equating it to 0. So minus 24 plus 6i minus 2v1 is equal to 0. So this will be minus 24 plus 6i minus 2v1, that is equal to 0. So what is my v1? I know that minus 24 plus 6i minus 2 into, what is my v1? v1 is the voltage drop across 4 ohm resistance, which is current times resistance, that is I multiplied by 4, which is equal to 0. I, because the current that is flowing through 4 ohm is nothing but this current that was mentioned in the question, which is I. So I times 4, minus 24 plus 6i minus 8i is equal to 0. So minus 24, that will be minus 2i is equal to 0, minus 2i is equal to 24. So you get your I as minus 12 amperes. So the main conclusion from this here is that is due to a 24 voltage source, the current that is flowing, that is I, which was mentioned in the question, is minus 12 ampere, which is to be noted. So in the second case, where we consider the effect due to 3 ampere current source, as you can see in the figure, previously there was a 24 voltage source which is now replaced by its equivalent short circuit, and have to calculate the current I by considering your 3 ampere current source. So now to calculate the current I due to 3 ampere current source, I can apply your KCL here at this node. Suppose I call it as A. So you can apply KCL here. So if you apply KCL, it should be, so this is the branch that contains of 2 ohm resistance and dependent source, as well as this is a branch which contains of 4 ohm resistance, and there is a 3 ampere current. So my current directions due to the respective branches is, this is the current that is entering into this node, and these are the current that is leaving this node. Obviously the current direction in this is assumed to be in the clockwise directions, but I assume as anti-clockwise direction in this question, and obviously it and the final answer I can replace it by minus sign with the direction that is given in the question. So the 3 ampere source that is entering the node, whereas this I call it as 3 ampere current, and this as I1 and this as I2. So my total KCL equation would be, that is the current entering is 3 ampere is equal to the two, this is I1 plus I2, these are the current that are leaving the junction. So my current entering is equal to current leaving as per the KCL equation. So this is equation, say call it as 1. So 3 is equal to I1 plus I2. What is I1? I1 is this current which can be replaced as I1 plus what is I2? I2 is this current that is flowing through your 4 ohm resistance, which can be replaced by I current is, which is voltage divided by resistance. So since the voltage across your 4 ohm is V1 divided by resistance is 4 ohm, and thereby further simplifying the equation, you get 3 is equal to what is I1. So here if you want to find out the current I1, so we know that current is nothing but voltage by times voltage divided by resistance. So here the voltage at node A is simply the voltage V1, right? So the branch voltage is nothing but V1. So similarly the voltage at node A is V1. So I write V1 as V1 minus 2V1 minus 2V1 divided by the resistance 2 plus V1 by 4. I hope it is clear, because here see here since the voltage drop across 4 ohm resistance is the same the voltage drop voltage across this branch, right? So the voltage at node A is similar, is nothing but your voltage V1. So V1 minus 2V1 divided by resistance 2, which is nothing but current, voltage by resistance. So further simplifying the equation, 3 is equal to minus V1 by 2 plus V1 by 4. So 3 is equal to, taking out V1 has to be common, I get 1 by 4 minus 1 by 2, which is nothing but minus half, I mean minus 0.25, 1 by 4 minus, yes. Now my V1 is simply minus 12 volts. So I get V1. So since I know the value of V1, I can calculate the current that is flowing through a 4 ohm resistance, which is I is equal to V1 by 4. Or simply here in this case, since I have considered it as I2, that is the current flowing through here, it is I2, I can write I2 is equal to V1 by 4. So what is V1? V1 is nothing but minus 12 divided by 4, it is nothing but minus 3 ampere. So since I know the branch current, that is I know the current that is to this branch is obviously 3 ampere, and the current to this branch is minus 3 ampere, I can calculate the current that is I, which was given in the question. So since I know that your minus 3 ampere, so I know that since in order to calculate the current I, which was given in the question, I then consider the case, the equations, that is 1, which was 1, question 1. So we know that 3 is equal to I1 plus I2. 3 is constant, that is fixed. I1 is the current through this branch. So I keep it as it is, plus what is I2? I2 is now calculated, which is nothing but 3 ampere. So I write it as minus 3 ampere. So I get 3 minus 3 is 6 is equal to I1. Since I've already said that I have assumed the direction that is opposite to as given in the question, since the actual current is flowing in your clockwise direction, but I assume in the while applying a KCL equation as in anti-clockwise direction, I should replace it with the minus sign. So my I1 would be equal to minus 6 amperes. So superposition theorem basically states that you have to calculate the current I due to both the sources, that is by considering 24 voltage source and by the effect of 3 ampere source. So I get the final equation as I is equal to I1 plus I2. So I1 plus I2. So I1 is the current due to 24 volt source. So let it be I plus I2, because since I have used the I1 and I2 in this equations, so let it be I plus I. This is I, one I due to your current due to 24 volt source, and another I is because of current due to 3 ampere source. So I is equal to, what is my current due to 24 volt source? Here it is minus 12 ampere, replacing it by minus 12 ampere minus current due to, considering the effect of 3 ampere current source, you get it as minus 6 ampere. So you get total current as minus 18 ampere. So here in this case, negative sign basically indicates that as in the mentioned question, it is in the clockwise direction, but negative sign indicates that the current is flowing in the anti-clockwise direction in the network. Thank you.